We're asked to find the exact value of tangent of 13 pi divided by 12 radians. To do this, we'll have to use the sum and difference identity for the tangent function shown below, because 13 pi divided by 12 does not result in a nice reference angle, or a reference angle in which we can find the exact trig function value for. The first step is to find two angles that have nice reference angles that have a sum or difference equal to 13 pi divided by 12 radians, or as we can see below, 195 degrees. Sometimes it is helpful to work with degrees first and then convert back to radians. For example, two angles that would sum to 195 degrees that have nice reference angles would be 150 degrees plus 45 degrees. Or in radians, because pi divided by 6 equals 30 degrees, and 30 degrees times 5 equals 150 degrees, 5 pi divided by 6 radians equals 150 degrees, and then we'd have plus 45 degrees equals pi divided by 4 radians, and the sum is 13 pi divided by 12 radians. These aren't the only two angles we can use, though. For example, we could also use 240 degrees minus 45 degrees, which also equals 195 degrees. Or in radians, because pi divided by 3 equals 60 degrees, and 4 times 60 degrees equals 240 degrees, 240 degrees is equal to 4 pi divided by 3 radians, and then minus pi divided by 4, which also gives us 13 pi divided by 12 radians. In the previous example, we used a sum of two angles to find an exact tangent function value, and therefore for this example, we'll use a difference. We'll use 240 degrees minus 45 degrees, or 4 pi divided by 3 minus pi divided by 4. To get started, we have the tangent of 13 pi divided by 12 radians equals the tangent of 4 pi divided by 3 radians minus pi divided by 4 radians. And now, so that we can find the exact trig function values, we'll go ahead and sketch the reference triangles for 4/3 pi radians and pi divided by 4 radians. Well, pi divided by 4 radians is going to be in the first quadrant. Let's say here. So this would be pi divided by 4 radians. And therefore we can label the two legs 1 and the hypotenuse square root 2. And now for 4/3 pi radians, which is 240 degrees, the angle is going to terminate in the third quadrant here, where the reference angle is going to be 60 degrees, or pi divided by 3 radians. So the reference triangle is going to look something like this, where the reference angle is pi divided by 3 radians, and the terminal side of 4 pi divided by 3 radians is the hypotenuse of the reference triangle. Notice 4/3 pi radians is equal to pi radians plus 1/3 pi radians. Pi radians is half a rotation, and then another pi thirds radians gives us the reference angle for 4/3 pi radians. But because the angle terminates in the third quadrant, both x and y are negative, and therefore we label the short leg -1, the long leg negative square root 3, and the hypotenuse 2. It is important that we sketch the reference triangles if the angles do not terminate in the first quadrant, so that we make sure we get the correct sign for the trig function values. And now applying the difference identity for the tangent function shown below, notice because we're using the difference of two angles, or we're using the minus on the left here, we're going to use a minus in the numerator and a sum in the denominator. This gives us the tangent of the first angle of 4 pi divided by 3 minus the tangent of the second angle of pi divided by 4, all divided by 1 plus the product of tangent of 4 pi divided by 3 and tangent pi divided by 4. And now we determine the tangent function values. Tangent of 4 pi divided by 3 using the reference triangle equals the ratio of the opposite side to the adjacent side, which is negative square root 3 divided by negative 1, which is square root 3. And then we have minus tangent pi divided by 4 is 1 divided by 1, or 1. In the denominator, we have 1 plus the product of tangent 4 pi divided by 3 and tangent pi divided by 4, which is square root 3 times 1. Simplifying, the exact value of tangent 13 pi divided by 12 is the difference of square root 3 and 1 divided by the sum of 1 and square root 3. Normally this will be fine for the exact value of tangent of 13 pi divided by 12. But just in case you're required to rationalize the denominator, I'll also show that work. Beginning with the given expression, to rationalize the denominator, we multiply the numerator and denominator by the conjugate of the denominator. The conjugate of 1 plus square root 3 is 1 minus square root 3. When multiplying, we have 4 products in the numerator and 4 products in the denominator. In the numerator, we have square root 3 times 1, which is square root 3. And then square root 3 times negative square root 3 gives us minus 3. Then we have negative 1 times 1, which is minus 1. And negative 1 times negative square root 3 equals plus square root 3. In the denominator, we have 1 times 1, which is 1. And then we have 1 times negative square root 3, which is minus square root 3. And then we have square root 3 times 1, which gives us plus square root 3. And finally, square root 3 times negative square root 3 is minus 3. Simplifying, in the numerator we have negative 4 plus 2 square root 3. In the denominator we have 1 minus 3, which is negative 2. To simplify, let's write this as negative 4 divided by negative 2 plus 2 square root 3 divided by negative 2, which simplifies to positive 2 plus negative square root 3, or just minus square root 3. We can also express the exact value as 2 minus square root 3. I hope you found this helpful.